Hi everyone, so today I would like to explain a little briefly about decision tree for financial level. So firstly, we are going to import the libraries that are going to use, which are NumPy and Pandas, and then we are going to retrieve the data set that will be used for this model. So for the data set, we actually pre-process it in RapidMiner, so we are only going to import the processed data set with the sampling distress level, and this is the columns, the attributes that we have in the data set, and then this one we are basically going to remove. We're going to drop this attribute because it's not going to be used for any target. And this one we trying to change the nominal attributes into numerical because we are going to calculate the performance, and the performance cannot be in nominal. So first we're going to change the attributes into category. After changing it to category, we will change it to numerical. So we're changing it to int. So if we describe, we are going to see that the health status and level distress is int 8. So this is the decision tree. So first we're going to drop all these three columns because we're not going to put this as the attributes that will be train and test, and the y_dt is the target. So our target for financial level is level distress, and this one is to split the data into train and test. So we have two ratios. We are going to experiment with two ratios, which are 0.6 and 0.8, or 60/40 and 80/20 respectively. So the first one is 0.4. This is for 60/40 ratios, and 0.2 is for 80/20 ratio. So now we will import the library for decision tree classifier. So this is the codes that we use. The criterion is set to entropy, random state 0, and max state is 10. So, and then we will import the library for classification report, confusion matrix, accuracy score, and precision score. And if we execute, then it will come out like this. So it shows the precision, recall, F1 score, the support. This is the classification report. As for the confusion matrix, it will show how much it is predicted correct for each class, which are distress level and low distress level. So for 00, it predicted 199 correctly, and for 11 is 133. And this is the performance accuracy, which is 68.31%, precision is 71.89%, and the performance error is 31.69%. And this is for hyperparameter tuning. This is basically to optimize and to see whether the accuracy will increase or not. Supposedly it will increase, but we will see. So for hyperparameter tuning, we decided to use grid search. So this is why we import the grid search CV from sklearn model selection. So this is the code example. This is the code that we use. The decision tree classifier is put inside the grid search. So this where the code is different for hyperparameter tuning. The rest are the same. So if you look here, then it will show the classification report, the confusion matrix, performance, precision, and the performance error. So if you look here, surprisingly, after hyperparameter tuning, the accuracy decrease instead of increase. So this is the same, it's just that we use ratio 80/20 here. And recent research is our second experiment. So for this one we use standardized data set that was done in RapidMiner, which is process Quark, and the steps are the same. We remove the unnecessary call attribute, we change it to category and change it back to int, and yeah, it's all the same as previously. And our third experiment is resampling, standardization, and discretization. So for this one we use the same dataset as standardization. However, the only difference is for age we are using age bin instead of standardized age. So that's why we remove the age here. And this is all for decision tree. Thank you.